You think the world exists on its own, finished, independent, unchanged by your presence. You imagine observation as passive, that looking does nothing, that measuring only reveals what's already there, and you assume reality behaves the same whether you're watching or not. This is wrong. At small scales, nature behaves one way when unobserved, and another when it is watched, not because you interfere, not because your tools disturb it, but because observation itself matters. This disturbed physicists. It unsettled Feynman, because if outcomes depend on observation, then reality isn't what you think. You are trained from childhood to separate seeing from doing, to believe observation is clean, leaves no marks, and doesn't change what is observed. You look at a chair, and it does not care. You watch a clock, and time does not hesitate. You measure a table, and it remains the same length. This feels so obvious it doesn't register as an assumption, only as fact. In everyday life, observation appears harmless. Your eyes catch reflected light, instruments register numbers, nothing pushes back. So you quietly adopt a rule: the world has properties first, and you merely discover them later. Physics itself was built on this rule, and for centuries it worked. But hidden inside it is a fragile assumption that observation can always be made arbitrarily gentle, that you could, in principle, look without touching at all. At large scales the illusion holds because the disturbance is too small to matter. At smaller scales it cracks because when what you observe is no longer solid, localized, or stable, observing stops being neutral. It becomes an interaction. And once observation becomes an interaction, the clean line between what is and what you saw begins to blur, not philosophically, but physically. At first, nothing seemed wrong. The experiments were simple, repeatable, carefully controlled. Physicists sent tiny things toward carefully arranged setups and watched where they landed one at a time patiently. They expected consistency. If the conditions were the same, the outcomes should be the same. That was the rule. That was how experiments were supposed to behave. But the results didn't settle down, change how the experiment was observed, and the pattern changed not slightly, fundamentally. When no attempt was made to track individual events, a smooth, spread-out pattern appeared structured, predictable, as if each particle somehow explored many possibilities at once. But when the setup was altered to record which path each particle took, the pattern collapsed into something simpler, cruder, as if those other possibilities had never existed. The disturbing part wasn't the difference in outcomes. It was the reason for the difference. Nothing about the source had changed. Nothing about the environment. Nothing about the timing. Only the question being asked of the system. The experiment did not respond to what happened to it. It responded to what was being checked. The same physical arrangement, the same particles, the same energies produced different results depending on whether information was extracted. This was not noise. It was not experimental sloppiness. It was not something averaging would smooth away. Nature was behaving differently because it was being observed differently. And no one liked that. The first reaction was relief. There was an easy explanation available, and it felt comforting. Observation, after all, requires interaction. Light has to bounce, fields have to couple, detectors have to click. So the story became simple measurement disturbs the system. You shine light on something small, and you kick it, you probe it, and you nudge it off course. The result changes because you were clumsy. This explanation preserved the old picture. Reality still existed, fully formed. You were just bad at looking without interfering. If this were true, the problem would disappear with better tools, gentler probes, smarter designs. But the experiments refused to cooperate. Physicists reduced the intensity of the measurement. They delayed the decision to observe. They removed detectors entirely and reintroduced them later. The outcome still depended on whether information could be known, not whether it was known, not whether anyone actually looked, just whether the experimental setup allowed the distinction to exist at all. Even when no signal was read, even when no data was recorded, even when the result was erased, if the information was available, in principle, the behavior changed. This is where the mechanical explanation collapsed. There was no extra push, no unavoidable disturbance, no hidden kick to blame. The system wasn't reacting to force, it was reacting to possibility. And that is not how objects are supposed to behave. Because now the problem was no longer technical, it was conceptual. Observation wasn't breaking reality, it was helping decide which reality occurred. At this point, the language had to change. The old words position, path, state were no longer behaving. They assumed too much, they assumed things were already decided. So physicists began speaking more carefully. They stopped saying what a particle is. They spoke instead about what it could be. Not ignorance, not missing information, something deeper. Before observation, the system was not hiding a definite answer. It was not secretly choosing one path while pretending otherwise. There was no single story waiting to be uncovered. Instead, there was a structured set of possibilities, not guesses, not options in your head, real possibilities, ones that could interfere with each other, ones that could cancel out, ones that could reinforce. But none of them on their own were facts yet. The unsettling claim was this: certain properties do not exist as actual things until they are observed, not revealed, not uncovered, created as outcome. Before observation, asking which one happened is the wrong question, because nothing has happened in that way yet. This is where intuition fails hardest. You want to imagine the particle traveling a path and merely refusing to tell you which one. You want to believe the answer is they're just inaccessible. But the mathematics and the experiments refuse that picture. The system evolves as possibilities, not as events. Observation doesn't interrupt that evolution. It ends it. It forces a transition from could be to is. And nothing in everyday experience prepares you for that. Feynman understood the mathematics. That wasn't the problem. He could calculate the probabilities. He could predict the outcomes. He could tell you exactly what numbers would appear on the screen. What unsettled him was not confusion. It was clarity. Because the equations were not vague about what they were saying. They did not describe particles with hidden properties. They did not describe trajectories you simply failed to notice. They described a process that only becomes definite at the moment of observation. And Feynman did not like pretending this was intuitive. He resisted the temptation to soften it, to explain it away with metaphors that made it feel classical again, to tell comforting stories about ignorance or disturbance. He warned against that impulse, because every time physicists tried to smuggle the old picture back in, the predictions broke. The math only worked if you accepted something deeply strange, that the theory does not describe what is happening, only what can be observed to happen. This wasn't mysticism. It wasn't philosophy sneaking in through the back door. It was the price of accuracy. Feynman was honest enough to admit discomfort. He famously said no one truly understands what is going on here, not because it's complicated, but because it refuses to sit inside common sense. The theory works precisely because it ignores your intuition. And that to him was the most disturbing part. If outcomes are not fixed in advance, then the universe is doing something unfamiliar. It is not unfolding a script. It is not revealing pre-written facts. It is holding possibilities open. This does not mean reality is vague. The probabilities are precise, the predictions are exact. What is missing is not structure. What is missing is commitment. Until observation occurs, the system does not settle on a single history. It evolves in a way that cannot be described as this happened or that happened. Those words arrive later. This is where people reach for comfort. They ask whether consciousness is special, whether the mind causes collapse, whether awareness creates reality. But the physics does not require any of that. No mind is needed, no observer in the human sense. Only interaction that makes information unavoidable. When a system becomes entangled with its surroundings, when distinctions are forced into the world, possibilities harden into outcomes. The universe does not wait for you. It waits for irreversibility, for a moment when alternatives can no longer overlap, when information cannot be undone. Until then, the future is not hidden. It is undecided. And the past, strangely, is not fully formed either. Because without a settled outcome, there is no single story to look back on. Reality in this view is not a timeline. It is a negotiation. By the end, the word observation no longer means what you thought it did. It is not looking, it is not watching, it is not awareness. It is the moment when a possibility stops being able to hide among others, when a distinction becomes permanent, when alternatives can no longer interfere, when information leaks into the world and cannot be taken back. Before that moment, asking what really happened is premature, not because the answer is subtle, because there is no answer yet. This is not a failure of knowledge. It is a feature of how reality operates. The universe is not built from facts alone. It is built from transitions, from undecided to decided. And those transitions are not smooth. They are abrupt. They redraw the story retroactively. Feynman was careful here. He did not claim reality needs an observer. He claimed the theory refuses to describe reality without observation. That difference matters, because it suggests something unsettling but precise. The universe is not a static thing you peer into. It is a process that only becomes definite at certain moments. Not all at once, not everywhere, but where interactions force it to choose. And outside those moments, reality is not wrong, it is unfinished.